Good day, all. I again hope all to be good. So now, I want us to again shift focus to functions, and I want us to start off with the quadratic function. So now, remember that the quadratic function would have the general form. So that would be this general form over here. So now that would be the f of x equals ax squared plus bx plus c. Also remember that the f of x would just be the notation of functions. So that would be how we write out functions or how we represent functions. So now with regards to the quadratic function, you will always have a power 2 there, or rather a power, a second order power. So now or rather let's settle with the highest power would be 2. So now if the a, so that would be the coefficient of x squared. If the a is greater than 0, so that would be a positive a, you then get a smiley face. So that would be a smiley face or concave down. If the a is less than 0, so that would be a negative a. So if the a is negative, then you get a sad face. And the sad face would also be concave up. So now I want us to also just look at the various points that you would actually be asked to find in a quadratic function. So now given the f of x equals ax squared plus bx plus c. So that would be the general form for the quadratic function. So now given the form, and you're also given the sketch as well, so that would be the parabolic function over there, or rather the parabolic shape. So this in itself would be the parabolic shape made from the quadratic function. So now you would have the point A. So the point A in itself is the turning point, which is also referred to as the axis of symmetry. So that's essentially where you cut the graph itself. So that would be where you cut it in half. So you can say that the equation for the axis of symmetry would be this x point there. So that would be the x coordinate of the turning point. So that would be x equals negative b divided by 2a. So now the equation for the turning point, to find the x value would be the x equals negative b divided by 2a, which is also the equation of symmetry for the quadratic function itself. So remember that you get the b. So the b you would get from there. So that would be the coefficient of x, and the a would be the coefficient of x squared. And this in itself would give you the x coordinate of the turning point. So now b, to find the y coordinate, actually, you would need to substitute in the x coordinate into the function itself. And then you should get the y coordinate of the turning point. So now point B would be the y-intercept. So that would be where the graph itself cuts the y-axis. So remember that this would be the y-axis, and that's the x-axis. Point C and D would be the x-intercept. So that would be where the graph cuts the x-axis. So the graph would cut the x-axis at point C as well as point D. To find the y-intercept, you would need to let x to equal 0. So once you let x equal 0, you then find the y-intercept. The y-intercept will have coordinates of 0 east to c. So that would be the the y-intercept there, which is the c. To find the c and d, which would be the x-intercept, you would need to let y to equal 0. So that's when you have the f of x equals 0. And then after that, you can then solve for x by either factorizing or using the quadratic equation. So now I want us to have a look at a question that I've prepared for you, gents. So now let's head on over to the question. So now the question asks, or rather given, f of x equals negative x squared minus 5x plus 3. So that's what's given. We are asked 1.1 to determine the y-intercept. So remember, to determine the y-intercept, we would need to let the x to equal 0. So now 1.1, so I will just have this in red. So now 1.1, you would have the f of x equals negative 2, 0 squared minus 5, 0 plus 3. And this will just give you the 3. So now it means that your y-intercept would be 0 is to 3. So that would be the y-intercept over there. So now 1.2 wants us to determine the x-intercept. So again, to find the x-intercept, you have to let the y to equal 0, or rather the f of x to equal 0. So let's move on to the next page for us to do so. So now 1.2, so let's just maybe quickly write out the equation. So that's the equation over there, minus 5x plus 3. So now for the x-intercept, we let the y to equal 0. So that would be that over there, minus 5x plus 3. We can multiply throughout by the negative so that the a is positive. So this would give us an x squared, 2x squared plus 5x minus 3 equals 0. We can then factorize. To factorize, we would simply just have the 2x there, the x, the 3, as well as the 1. This bracket will have a negative, whilst the other has a positive. To solve for x would equal a half, or x would equal negative 3. So now this in itself would be your the x coordinates of the x-intercept. So now the x coordinate of the x-intercept, and then we can write it in coordinate form as that. So now these would be the x-intercept, or rather the coordinates of your x-intercept. So now let's move on to the third question. So that the third question wants us to calculate the coordinates of the turning point. So now remember, for the turning point, we would need to make use of this formula over there. So now let's move on to the next page. Or actually, I think we can utilize this side here. So now this would be x equals negative b divided by 2a. And then this in itself would be negative 5. So remember that would be the b, divided by 2. A would be negative 2. So that would be the negative 2 there, which is the a. This in itself would give us a negative 5 divided by 4. So that would be the x-intercept of the turning point, which is also referred to as the axis of symmetry. So now to find the y coordinate, we would need to sub in the x coordinate of the turning point. So that would be -5 divided by 4, which equals negative. So I'm just going to sub in where there's x. I will sub in the x coordinate. So let me just undo that a bit. And then 5, -5 divided by 4 plus the 3. And then this in itself should give me a value of 49 divided by 8. So we can rewrite the coordinates of the turning point as a -5 divided by 4 as the x coordinate, and the 49 divided by 8 as the y coordinate. And that should be the solution for 1.3. Thank you for having me. Please do have yourselves a very good day.